All right, thanks, Pablos, for the introduction. To some, it might seem like an unlikely combination of subjects to be talking about advanced nuclear energy and innovation to a Nordic summit in Seattle, Washington. And Pablos began to connect some of those dots, but I assure you that those topics really go together in my mind because it turns out that I lived in Roma, Finland for several years, building one of the world's latest nuclear power plants to get connected to the grid, the Olkiluoto plant, that's providing enough power for 1.6 million homes, and it's helping Finland demonstrate its energy security from Russia, which is just a couple hundred kilometers away. And I am really, really impressed with the Nordic region's leadership, not just in nuclear energy, but in its climate focus. I've also ski toured in Svalbard, Norway. I'm very, very aware of and impressed with the Nordic region's beautiful seascapes and landscapes. And if I were you all, I would be so motivated to protect those as well. Of course, the Nordic region is also a very innovative region, and Seattle is known for being the same, but as Pablos mentioned, normally you think of Seattle innovation as being innovation in computing. Well, it turns out the Pacific Northwest is also a hub of innovation for advanced nuclear energy. I also wanted to recognize that Nordic countries like Finland are really taking a lead, not just in deploying new nuclear energy, but in showing that the waste solution is here, and that is geologic disposal of the used fuel. You know, there's no smokestack at a nuclear plant. The entire waste stream is a small volume of used nuclear fuel. And in Finland, with the Posava geologic repository, Finland is the first country in the world to demonstrate that they have that solution, and they're storing used fuel geologically, and Sweden is following suit. Before moving on, I'd be remiss in not observing one thing I learned living in the Nordic region, and that is the excellent public education. And I really think that's instrumental in helping countries like Norway, Finland, and Sweden make those long-term decisions for their people and their society. So Bill Gates is TerraPower's founder and chairman, and makes a pretty strong statement here. Solving climate change is the hardest thing mankind has ever attempted. So coming from Bill Gates, who's done some very hard things in computing, in fighting the pandemic, and on multiple climate issues, it makes you wonder why he would say this. Well, it turns out that fighting climate change requires working on almost every aspect of our economy. Not only do we need to reduce and eliminate emissions in producing our electricity, but also in ensuring that we have transportation, ensuring that we can reduce emissions from the industrial sector. It's everywhere in the world. Some of you might have read a book by Vaclav Smil called How the World Really Works. In his book, Vaclav points out the 4 pillars of modern society. Those are steel, concrete, plastics, and ammonia. And it turns out to produce all of those, on which our society is really built, all of those are highly, highly carbon intensive. And in the case of ammonia, which is used extensively for fertilizer, that's how we feed the approaching 10 billion people that Pablos was talking about, right? When a lot of us were born, the world was fed with organic fertilizer crops. We're only able to feed the 8 billion people in the world now because of ammonia. And Sven Tor Holseter, who's the CEO of Yara in Norway, a fertilizer producer, points out that Europe is highly dependent on Russian fertilizer today. So dependence on Russian fertilizer in Europe is energy dependence, because that fertilizer produced in Russia is highly carbon intensive. So food dependence and fertilizer dependence on Russia is in fact a form of energy dependence in Europe on non-clean sources. So I mentioned there's a real need for innovation in nuclear. Nuclear has been providing 20% of the United States electricity for close to 60 years. There's 400 nuclear plants around the world. It's widely deployed across Europe. France is close to 80% nuclear. But the problem is we haven't really innovated in nuclear. The technologies that are powering those 400 plants, they're very safe, but they're 60 years old. We really avoided innovation in nuclear science and engineering because of some of the discomfort and dogma that Pablos referred to earlier. It was always easier not to seek new regulation or not to seek public acceptance by not changing anything. And that might have been the right way to go to get one more plant licensed or life extension on another plant. But if you do that for 60 years, you have 400 nuclear power plants around the world that are based on pretty old technology. So our founders, including Bill, realized this when they started TerraPower over 15 years ago. Today's nuclear plants are all cooled with water. Again, they're very safe. We need to extend the lives of these plants in the US and Europe from 60 to 80 years, maybe 80 to 100 years. That's very safe, and we have great regulators all over the world overseeing this. But that older technology is more expensive. Using water as a coolant makes you have to build plants that have these heavy containments that you know nuclear power plants for. And that adds cost. And as we grow our electricity supply, cost is going to be a big driver. And nuclear absolutely needs to move on in technology if it's going to improve its economics. So that's really the motivation for TerraPower, is there's a huge electricity demand and the need for innovation. And TerraPower has been working at this for over 15 years now, and Pablos was involved at the very beginning at Intellectual Ventures. We had to cross two valleys of death in development of the Natrium technology. The first one was in basic R&D. The second one was the harder and more expensive one, which is commercialization. And we're doing that with the US Department of Energy. We've won a very large Department of Energy grant, $2 billion. And that's helped us raise over $800 million in private funding to build that first plant. So we won't get into nuclear physics this morning, but just at a very high level to talk about some of the changes that have come through innovation. First, Natrium is still about nuclear fission. We looked at fusion when the company was founded. We had some experts in fusion who were involved, and the founders decided 15 years ago that for the needs this century, advanced nuclear fission was really the way to go. We think fusion should be pursued with research and development efforts, but as far as having something we could scale in the 2030s, advanced fission is the way to go. So the heat source is breaking uranium atoms, and as Pablos pointed out, a tremendous amount of heat is released. And then we use two new fluids. Instead of using water and to cool the reactor and make steam, we have two new fluids here. We cool the reactor with a liquid metal, melted sodium. That allows the reactor to operate at very low pressure. It allows you to have a plant that's lighter and more economic. And then instead of making steam right away with that heat, we introduce another working fluid that's molten salt. At many solar plants today, the heat from the sun is stored in molten salt so that when you have clouds and there's still continuous electricity demand, you can take the heat out of the molten salt and continue to make steam and generate electricity. So we're kind of borrowing this technology from the solar industry. And that gives us a nuclear power plant that operates in a totally different way than past plants. Past nuclear power plants kind of operated 24/7, and other things peaked throughout the day when demands changed or when sun or wind power was curtailed. So Natrium really does both of those things. It runs 24/7, but it also is able to flex power quickly throughout the day because it has built-in energy storage. We absolutely need nuclear to have an emission-free energy supply. Even if you put the climate challenge on the side, We've talked about the tremendous electricity demand growth coming from data centers. And if you looked at any of the projections from a year ago, you can raise them today based on generative AI and what that's going to do for the data needs. So we have this tremendous new demand for electricity. After about 30 years of pretty flat electricity demand in the US and Europe, so we've been actually a little bit complacent in not realizing that we have to invest in new generation. But if it weren't enough to double or triple electricity demand between now and 2050, because of our climate challenges, we're going to be shutting off most of our fossil fuel. In the US, 25% of our coal plants will retire by 2029. And coal plants, although emission intensive, they do run 24/7, and they've provided us with a reliable grid for decades in the US and Europe. And so we're shutting off the coal plants and replacing those with wind and solar, which are great. We're big believers at TerraPower in a massive expansion of renewables, but we do need to recognize that wind and solar are intermittent. And in parallel with the wind and solar, you need to build something that runs 24/7, and you need to build storage. And Natrium checks both of those boxes. There's multiple studies now that are confirming that an emission-free grid can be best completed with lowest system cost with 20 to 30% nuclear. There's studies by MIT that are confirming this. There's studies in Europe. And even here in Washington, Energy Northwest did a study demonstrating that 20 to 30% nuclear was the optimal way to complete a carbon-free grid. And in fact, it said that by doing so, you could save $8 billion a year. So the population of Washington State is 8 million people. Imagine by incorporating 20 to 30% nuclear, you could save $1,000 per citizen. I fully expect Washington State to have additional nuclear plants in the future. There's a water-cooled reactor called Columbia Generating Station that's been operating safely and reliably for decades. And I expect new reactors to be built in Washington. However, our first plant that we're building in partnership with the Department of Energy will be built in the state of Wyoming. This is going to be America's next reactor. We have started the whole process. We have 1,000 design engineers working on the project, and we just submitted our construction license application to the NRC. This first Natrium plant will be built at the site of a retiring coal plant, where we'll be able to reuse the grid connection, the cooling water, and the staff at that plant. So I understand we have further discussion coming up in a panel. Really looking forward to that discussion on advanced nuclear. And Brian Young will be joining me from the Washington Department of Commerce for that discussion. Brian?